All right, so this is our number 5 in the series of remove environmental risks from the transaction. And because it says number 5, you have guessed right. If you guessed that we had several before that, you can see all of them at www.amirdini.com. And if you don't see them, call me at 323-899-5001. And the series has more than 30 videos in it, because if we were to do it all in one lump sum, it would have taken us at least 2, maybe 3 or even 4 hours. And I do not expect you to sit 3 or 4 hours or even an hour or so and just listen to me. So we are trying to cut them short into within the span of maybe 20 minutes or so. So we have over 30 of them. And I've been doing it since 1988, phase 1 and phase 2 environmental site assessments. And I am what they call environmental professional. I qualified as an environmental professional. And I should tell you that I'm not the only one on this planet or in this country that is considered a qualified environmental professional. There are quite a few of us around, and I'm very, very proud to belong to this professional group. And environmental professionals are defined, the qualifications of environmental professionals are defined by the United States EPA. They have a whole section there telling us and you who is or what is an environmental professional. And if you go online and just search for EPA, environmental professional keywords, you will get there, you will see the complete description. And the SBA, the Small Business Administration of the United States, this is a big administration which stands behind most, if not all, of the commercial loan transactions nowadays. And the most institutional lenders have adopted rules of the SBA. And the SBA has declared that all loans for all commercial loans must be backed up by environmental investigations. And they require environmental investigation reports, and they say that those can be done only by environmental professionals, and environmental professionals are those whom the EPA has declared to be, has qualified or has described as an environmental professional. So there is this, you go to the EPA and you will see all these descriptions there, who qualifies, what was the criteria, and all of that. For myself, I graduated in 1964 in mechanical engineering. So this was a long time ago. Just tell you that I've been around and I still feel younger as ever and energetic as ever, probably even more energetic than ever. And so graduated in 1964 in mechanical engineering with additional credits nuclear and chemical engineering. And I spent the next 8 years in nuclear facilities, first in the operations, then in the maintenance, then in the construction of facilities in a nuclear place, and then moved to the chemical industry, spent another 12 years there. Here is a refinery that I work with, and I worked with several designed, constructed, operated some chemical plants, and eventually became a general engineering contractor in California. And I started my career in Israel, that's where I was born, and moved to the United States, and then moved to California, and in 1989 became a general engineering contractor with a specialized classification called the hazardous substance removal certification. So have been doing it since 1989. So that's what 34 years almost. And looks like yesterday, of course, and removing hazardous substances. And along the way, I was registered with the state of California, and they had a special registry for 24 years between 1988 and 2012, They discontinued it in 2012 because they did not have the budget, but they had it for 24 years, and it registered environmental professionals. And I was what's called level 2 environmental assessor, registered with the state of California. And as such, I qualified because I completed all of the requirements for the most stringent level of environmental registration provided by the state. REA2 is a project manager who can conduct all assessments and investigate plus issue cleanup opinions. So I was qualified to investigate and issue opinions, cleanup opinions to the state of California and evaluate the risks from contamination and manage the cleanup of the contaminated sites. And these was all recognized by the state so that we can basically had some fiduciary duty, if you wish. Once we worked under oversight of regulatory agencies, we had those fiduciary duty to the agencies. And again, I'm very proud to have been in this registry, and I'm not the only one. There were several of us, and they are still around, and I'm very proud and happy to belong to that group. Here is a recent project that I managed, and we've done it in a place called Silver Lake in the city of Los Angeles, California, a pesticides facility. Terminix used to own it and operate there, and they mixed and distributed and basically contaminated the place. And when our client wanted to put an apartment building here, and we had to clean it up to the most stringent demands of the Department of Toxic Substances Control. It's a Department of California EPA, which oversaw the project. And we had the inspectors, the regulators coming to our site to visit us regularly to see that we are doing what we're supposed to do right. And you see here the concrete is, all this debris is impregnated with pesticides. You see the soil, it's laden with pesticides, and we excavated it, and we broke the concrete. And in order to take it out, we took out over 1,000 tons of contaminated concrete. We took out over 1,000 cubic yards of contaminated dirt. And when you excavate it and you put it on the trucks, guess what? You make a lot of dust. You really make a lot of dust. And guess what? This dust is laden. It is laden. It is contaminated with pesticides, and dust flies around. So now you have flying dust. And then flying dust, which is contaminated and can be inhaled by whom? By the families that are around it, families and children and old people, very sensitive. And inhalation, and we'll talk more about it later in later coming presentation. Inhalation is one of the worst ways for the body to get contaminated. Ask those who smoke stuff, all right? So anyway, so we had to defend, we had to protect them. And you see us watering here, the sand, but we did not only water it, we had monitors all around the site, monitoring the dust, monitoring the air for dust every minute of the day, all right? And if the dust level in the air, say, went over, exceeded a very minute level, we shut down the operation right away. So it was pretty onerous, pretty heavy, and we had to be very careful here. And again, I'm very, very proud to have done it. And right now we have there an apartment building, 16-unit apartment building. So this is a sample project, what professional environmental professionals are doing. The Einstein, he says, if you cannot explain it simply, you don't understand it well enough. And you may have already noticed that I'm doing my best to explain it simply, but I have the, what do I say? I have the fault of many professionals that we get so used to the things that we understand and know that we think that everybody knows them. So sometimes we don't bother to explain things which for us are as simple as the sun rises in the east. I mean, what do you mean? You don't understand it? How come? and we don't understand that you don't understand, all right? So anyway, so I may be at fault sometimes, but I'm doing my best to explain it simply so that you will believe me that I don't understand it, that I understand it well enough. So talking about plumes, okay, and we talked about it before. What is a plume? We have the word plume a lot. We use it in our industry. And a plume is something that originates at a point like this feather. It originates at a point and then it expands, all right? A plume of feather. So here we have this knight, this armored knight, and he seems to be very proud because he has a plume on his helmet, okay? The plume starts at a point and expands, all right? And here we have our stacks, our chimneys. They belong to this power plant or industrial plant, and they emit all this smoke out there, and this is the plume of smoke. And it starts at a point and it expands. So you have a plume. And in the environmental industry, we talk about a lot about plumes of contamination. Start at the point and expand. So here we have a plume. And a plume of what we call, and now let me give you a headache, a word that we use, it's called L-napple. And I'm using this word because it is in this clip that I clipped from another manual, and they had the word. So now I have to explain it to you because I could not find the pictures that did not have the word. So L-napple. L-napple, look on the upper right, is light, non-aqueous phase liquid. So all what it means in those complex words, that L-napple is this kind of liquid which is lighter than water. And it's a liquid that will float on water. So if you take a gasoline, here we have gasoline is L-napple. It's lighter than water, it will float. You take this olive oil here, it's L-napple. It will float on the water. It's lighter than water. You take the acetone, it will float. Okay, so all of these guys are L-napples. They are lighter than water. So we have here an L-napple spill site. Okay, you have the land surface and whatever, something spilled here. Okay, maybe it's a landfill, whatever. Something spilled, and you have the, shall we call it orange? This kind of orange L-napple body. This is where the fluid enters the soil and it migrates down as liquid, as fluid, okay, in a liquid state. It migrates down, it saturates the soil and moves down as liquid, down, 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 hits the water table. The blue is the water table. The black line here is the water table is the black line, and the water under it is the aquifer. And as I explained in the previous presentation, aquifer is basically soil saturated with water. It's not a lake, it's not a river, it's soil which is saturated with water, like the soil, like the sand in the beach. You dig down into the beach sand and you will hit water, all right? It's saturated. So that's an aquifer, and here we have the L-napple, this gasoline or acetone or oil or diesel or whatever, coming down as a liquid, saturating the soil, hitting the water, and spreading as a pancake over the water table. So here we are, it's lying, and it floats. It floats on the water, and the direction of the water flow, you see down the arrow, the direction of the overflow is to the right. So it kind of moves a little bit with the water flow, but doesn't move much. You will see it moving, definitely, but it's the main motion of its moving is because it's being pushed from above. It's pushed and it spreads like a pancake and it moves. And it moves very slowly over the years. It moves slowly, bam, 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 bam. It will move a little bit far away. It doesn't move too far, okay? Those L-napples, those liquid states, they move, but not moving too far, all right? And then right under it, there is this light blue is the plume of soluble L-napple. Like you take a gasoline, to a degree, gasoline dissolves in water. To a degree, even oil or acetone, they dissolve in water, like salt and sugar, but not to the same degree, of course, as salt and sugar. The solubility is very, very low, but they still dissolve in water. And then they move those particles that dissolve in the water, they move with as the water moves, it moves with the water. The liquid stuff rests on the water and get pushed by the water, but the dissolved stuff just move with the flow of the water. If the water is moving 10 yards a day, this thing will move 10 yards a day, all right? So it moves with the water, all right? This is the soluble stuff. So this is this contaminated aquifer. Here we see a case in point. This is a gasoline station here on the corner. I show you in my laser point, and it contaminated. The tanks leaked big time in a very large way. And the purple stuff is this gasoline, which is floating on the water. You can see the gasoline station here is a corner, and this pool of floating gasoline has left the station and moved a little bit outside. The green, the various shades of green are the dissolved gasoline, and the density of the shade is like the density of the solubility of the soluble gasoline in the water. And it moves, and you can see that the soluble stuff is moved across the street and moved over into the neighborhood. So it moved quite a distance. So here you have a plume of gasoline starting with a liquid floating on the water and moves down the neighborhood. Here is another case of a plume of certain contaminants. I forget what it is, but anyway, it's in redwood country up north near Oregon, and here this is water. Here this is exposed water. This is river and lakes, and it moved down with this is contaminated water. It moved down. Here's my client's property. It comes under the property, and the property is contaminated. Here is another recent case that I was in touch with, and this is here. This is a historic gasoline station, and again you see this dense red stuff. This is the liquid gasoline that is floating on the water. Then the various shades here are basically the soluble gasoline that is migrating here and migrating here to the left and moving, but this is about the extent of the entire plume. It doesn't move forever. I would say with gasoline stations, the most that I've seen a plume of dissolved gasoline moving in water would have been maybe, I don't know, 300 feet, 400 feet, and maybe 500 feet. But it doesn't move. Those plumes from gasoline stations, I have not seen them moving far and wide. But still, you can see this gasoline station contaminated the neighborhood. It's an issue. This is another cross-section of the same station, just a cross-section. Here are the tanks that leak. Here is the stuff that is floating on the water. This is the dense gasoline. Here, the dense color is the liquid stuff, and then the lighter color are the dissolved stuff that moving. This is a cross-section moving away. But in this case, it's kind of complicated because we are sitting in an oil, I call it oil country. We have oil coming from the ground. I mean, natural petroleum seeping out from the ground. This site is not far away from Beverly Hills here in Los Angeles. And we have lots of oil in the ground, and it's seeping out. Sometimes you go in the streets and you see the tar seeping out in the streets. Okay, you have La Brea tar pits, for example, in Los Angeles, you have the tar coming out. And this tar is coming out and entering into our plume, and our gasoline is now, our wells that we put there have tar in it. And all what I'm trying to tell you is that with this tar around, we cannot remediate it. We cannot remove the gasoline because we have the tar. So it's kind of a complicated case. The Alexander Graham Bell says, when one door closes, another opens. But we often look so long and so regretfully upon the closed door that we do not see the one which has opened for us. And I see it again and again in our real estate transactions when there is a problem and some of the prospective buyers are just seeing the closed door. They don't see the opportunity there that opens up. They don't look for the open door. And believe me, there are quite a few open doors. Just look for them and find the other door that can open. This is so true. And thank you very much for being such a good audience. Call me. I'll talk to you anytime at 323-899-5001. Visit our website at amirdini.com. Thank you very much, and I'll see you in the next one.